Hi, now we can discuss about the spin-spin interaction, that is the third part of this NMR. In this spin-spin interaction or spin-spin coupling, commonly called as SS interaction or SS coupling, when you consider a low resolution NMR spectrum, that spectrum consists of only signals, broad signal or sharp signals. We know NMR spectrum, that is a plot between the intensity versus the magnetic field, and it is denoted in delta unit or chemical shift unit. Chemical shift varies from 0 to 10, and normally we are getting signal at delta equal to 0 due to TMS, that is the standard reference. Signals of our compounds are compared with the TMS, and the signals of our compound that will come left to the signal of TMS that we found. And this type of spectrum, that is known as the low resolution spectrum, where we are producing a lower magnetic field. So each set of proton gives a signal depending upon the field felt by the proton. They give signals left to the TMS, and the difference in position between the signal position of a set of proton from the TMS, that is known as the chemical shift. And in the spectrum, this is the upfield region or higher field region. This is the downfield region or lower magnetic field region, right? And there present two types of protons in our compound, shielded and de-shielded. De-shielded protons can be seen nearer to TMS, and de-shielded protons are seen away from TMS with a larger value of chemical shift. So higher the value, more will be the de-shielding. Lower the value of the chemical shift, smaller will be the de-shielding or more will be shielding. So shielding of proton produces signal nearer to the TMS. De-shielding a proton shifts the signal away from TMS with larger value of chemical shift. I told you, in the low resolution we are getting broad signal like that left to the TMS. But when you take the NMR spectrum in a higher resolution, when you take the NMR spectrum in higher resolution or higher applied magnetic field, see the difference? Each signal will be splitted into a set of small signals. Each signal will be splitted into a set of small signals, and this type of splitting, that is known as SS interaction or SS coupling. And this type of set of sub-signal formation, that is known as multiplet formation. So such a set of signal containing smaller signals, that is known as multiplet. M-U-L-T-I-P-L-E, multiplet. Sometimes the signal consists of two signals, then it is known as doublet. Sometimes it contains only a single signal like this, single line. That is a set, that is known as singlet. This is known as doublet. Sometimes it consists of three lines, three sub-signals like that. It is known as triplet. So depending upon the number of sub-signals, present in a signal, we can classify the signals into singlet, doublet, triplet, quadret, pentet, hextet, septet, octet, like that. So this is known as formation of multiplet. Why we can see the multiplet structure in higher resolution or in a higher applied magnetic field? The reason is said to be SS interaction or spin-spin interaction. And here we know, you consider a compound like CH3 single bond CH, single bond Cl, CH3 CH Cl2, CH3 CH Cl2, where there present two types of protons. The two types of protons, they are in different chemical environment. Protons which are in the same chemical environment are said to be similar. And here there are present two types of protons, two different chemical environments in which the protons are situated. So the chemical environment of these three protons, that is not equivalent to the chemical environment of this proton. Since they are in different chemical environment, they are said to be different. So we can categorize the protons into sets depending upon the chemical environment, and we can label the sets of protons using alphabets like A, B, C, etc. What is meant by A? A is a set of proton which are in a chemical environment. B is a set of proton, and the chemical environment of B set of proton is somewhat different from A set and C set. And C is another set of proton. The chemical environment of that set of proton is different from A and also B. So depending upon the number of sets of protons, we will get signals. So the number of signals given by a compound depends on what? On the number of sets of protons. Okay? Number of signals given by a compound, that is equal to number of sets of protons. Now you consider this proton. Here the three protons are in similar chemical environment, and here there present no chlorine. There is no chlorine nearer to the CH3. Chlorine is away. So the three protons are similar. They are in a similar chemical environment, and they are said to be A set of proton, A set. And see, the chemical environment of this proton is different because it is situated in between the methyl group and also chlorine. Chlorine is electron withdrawing. Therefore, the electron present around this proton is smaller. The electron density is smaller. Therefore, the chemical environment of this proton is somewhat different. So, we can label it as B set. Right? Now, there the compound gives only two signals. The compound can give two signals because there are present two sets of protons. Right? And which signal, either due to A set or B set, will be seen nearer to the TMS? We know in the case of NMR spectrum, we will get, actually we are having a TMS signal at the far extreme right. Actually we are taking TMS along with our compound. Our compound is always mixed with the TMS while taking the NMR spectrum, and we are actually calculating the signal position of our compound with a reference to TMS. Already I told you. Now, so this is the TMS signal, and in this compound can give two signals which will be nearer to the TMS, shielded. Which is shielded? Which one is shielded? CH3. Why it is not shielded or de-shielded? Because of the presence of chlorine. Chlorine is electron withdrawing. Therefore, electron density present around that proton is lesser. So, CH3 proton that will be shielded more than that of the CH proton. So, signal due to CH3 or signal due to this set or signal due to A set, that will be seen nearer to TMS. Right? And see the signal intensity. Signal intensity refers to the signal height. And here there are present three contributing protons. So the number of protons definitely determine the signal intensity. Signal intensity depends on the number of protons. Larger the number of protons, more will be, or higher will be the intensity. Therefore, this signal corresponds to three protons present in A set. This B set containing only one proton, and that proton is less shielded because of the presence of chlorine. So signal due to B, that will be seen away from TMS. See, what is the intensity? Intensity will be smaller. Why it is smaller? Because the contribution is only from one proton. So this is known as the low resolution spectrum. Right? So the low resolution spectrum consists of number of signals away from the TMS and the signal that defines the number of types of protons. Position of signal defines the chemical environment, how far it is shielded or how far it is de-shielded. But when you take the spectrum of the same compound under higher resolution, under higher magnetic field, see the signal due to this proton, that will be splitted due to the influence of the neighbor, and the signal due to this proton, that will be splitted due to the influence of the neighbor. So neighbors always distract, right? That is a normal policy. Neighbors always distract. Therefore, as far as this proton is concerned, this is the neighbor. The presence of this neighbor will disturb the magnetic field of this proton, CS3 proton. Similarly, the three protons will affect the magnetic environment of this proton. Due to the spin interaction of the neighboring protons, each signal will be further splitted. The interaction between the spin moments of the neighboring protons, coupling or interaction between the spin moments of the neighboring protons is known as spin-spin interaction. And due to the interaction or as a result of the interaction, the signal will be subdivided. The signal will be splitted into multiplets. That means, here you consider another example. See, you consider the CH3CH system. Here we are forgetting about the other atoms connected to the CH. So, the CH3 proton, this is a set of proton, this is another set of proton. This gives a signal, this also gives a signal, right? This also gives a signal, and this signal will be nearer to TMS, this is away from TMS for the time being. As far as this signal is concerned, see, the spin magnetic moment of this proton, that will be disturbed, that will be coupled with the spin magnetic moment of the neighboring proton. As far as these three protons are concerned, which one is the neighbor? Neighbor is this one. So this neighbor will distract, this neighbor will disturb or perturb the magnetic moments of these protons. So when you consider a proton alone, it has got a magnetic moment. And when you consider another proton present in another carbon atom, this also has got a magnetic moment. And this magnetic moment of the neighboring proton, as far as this proton is concerned, this is its neighbor. The magnetic moment of this neighboring proton will interact with the applied magnetic field. As a result of this interaction, this magnetic moment will disturb this one. Therefore, signal due to this proton will be affected by the presence of this neighbor. So, how many sub-signal that you will get here, that depends on the neighboring protons, number of the neighboring protons. Therefore, the interaction between the spin of the neighboring protons, which causes further splitting of a signal, is known as SS interaction. This means that signal due to this proton, this is the signal due to this proton, that will be disturbed by the presence of the neighboring protons, right? Signal due to this proton, that will be disturbed by the presence of this neighboring proton. This is the neighboring proton for the time being, for the set of protons. And the number of signals or the number of subsignals in a set of that is given by n plus 1. n plus 1, where n is the number of neighboring protons. N is the number of neighboring protons. If there are present only one neighbor, that neighbor causes the splitting of a signal into n plus 1 or 1 plus 1, that is equal to 2. So here you are getting a doublet. And then suppose n is equal to 2, if there are two neighbors to a set of proton, the signal due to a set of proton will be affected by the presence of two neighbors, and the signal due to that set of proton, that will be divided, that will be splitted into n plus 1 due to the presence of two neighbors into 2 plus 1 equal to 3. Therefore signal due to that set will be splitted into a triplet. So there, remember that signal due to a set of proton will be splitted by the neighboring protons into n plus 1. Signal due to a set of proton will be splitted into a multiplet containing n plus 1 peaks, and where n is the number of neighboring protons. So you consider again this one CH3 single bond CH system. In the CH3CH system, the CH proton, this gives a signal, right, and a low resolution. This signal due to this proton, that will be disturbed by what? Disturbed by the presence of neighbors. How many neighbors it has? This proton has how many neighbors? 3 protons. So as far as this proton is concerned, there are 3 neighbors. So what is the n value? N is the number of neighbors. How many neighboring protons? How many neighboring protons? N is equal to 3. N is equal to 3. So we can apply the n plus 1 rule. On applying the n plus 1 rule, n plus 1 is equal to 3 plus 1. 3 plus 1 is equal to 3 plus 1, that is equal to 4. That means the signal due to this signal, that will be splitted into a subset containing 4 subsignals. So the signal due to this will be splitted into a set containing 4 subsignals. So the signal will be converted into a quadret, QUARTET. So why the signal due to the CH proton is changing into a quadret? Due to the presence of 3 neighboring protons. So presence of neighboring protons will disturb the signal, and that causes the splitting of a signal into multiplet. The interaction between the spin magnetic moments of the neighboring protons with the magnetic moment of the applied magnetic field, that is known as spin-spin interaction. Or in simple way we can say it is the coupling, it is the interaction between the magnetic moment of the neighboring protons, right? Now you consider the signal of these 3 protons. The 3 protons are in similar chemical environment, so it produces a signal, right? It produces a signal. Now under higher resolution, under higher applied magnetic field, this signal will be splitted. The number of the subset present in this subset, the number of the subsignal present in this, that is determined by whom? By the number of the neighbors. So as far as these 3 protons are concerned, who is the neighbor? This one is the neighbor. The one hydrogen is the neighbor. Number of neighbors, n equal to what? N equal to 1. You apply n plus 1 rule. On applying the n plus 1 rule, n plus 1 is equal to 1 plus 1, 1 plus 1 is equal to 2. So the single signal due to the 3 protons, that will be splitted into what? Into a doublet. Into a doublet. There are present 2 lines. The splitting of the signal into doublet. The splitting of the signal into a doublet causes by whom? Causes by the neighbor. And the neighbor causes the splitting of a signal into a multiplet. And the interaction between the spin magnetic moment of the neighboring protons with the magnetic moment of the applied magnetic field, that is known as S-S coupling or S-S interaction. And due to the interaction, a signal will be splitted into a multiplet. Number of the multiplet or the number of the subsignal produced in a signal depends on the number of neighboring protons, right? And how many subsignals we are getting? The number of the subsignal equal to n plus 1. What is n? N is the number of neighboring protons, right? And intensity of the subsignal. All these subsignals are not having the same intensity. Intensity of the subsignal, that depends That depends, or that can be calculated using this equation r plus 1 raised to n. And you expand. The coefficient of this expansion gives the intensity of the subsignal. The coefficient of the expansion gives intensity of the subsignal. So what is n? N is the number of neighboring protons. N can be what? N can be 0. N can be 1. Neighboring proton can be 1. N can be 2. N can be 3. N can be 4. Like that. Suppose n equal to 0. When n is equal to 0, what you are getting? R plus 1 raised to 0. Any quantity raised to 1? Any quantity raised to 1? 1. So you are getting a singlet. Right? Suppose n is equal to 1. When n is equal to 1, r plus 1 raised to 1. That is r plus 1. What is the coefficient? 1, 1. R the coefficient 1. So 1, 1. You are getting 1, 1. So you are getting a doublet with equal intensity. That is the meaning. Suppose n is equal to 3. Suppose n is equal to 3. When n equal to 3, r plus 1 raised to 3. Sorry, r plus 1 raised, suppose n is equal to 2. Sorry. When n is equal to 2, r plus 1 raised to 2. Expand it. On expansion, what you are getting? R square plus 2r plus n. R square plus 2r plus 1. What is the coefficient? The coefficient 1 is to 2 is to 1. So here you are getting a triplet. With intensity 1 is to 2 is to 1. In that way we can calculate the intensity. Suppose n is equal to 3. R plus 1 raised to 3. That is equal to r cube plus 3r square plus 3r into 1 plus 1. What are coefficients? Coefficients are 1 is to 3 is to 3 is to 1. So when you add these, you are getting a triangle, and that triangle, that is known as the Pascal's triangle. And from the Pascal's triangle also we can identify the signal intensity. When n equal to 0, you are getting only singlet. When n is equal to 1, you are getting a doublet with equal intensity. When n equal to 2, you are getting a triplet with a ratio, intensity ratio 1 is to 2 is to 1. When n is equal to 3, when the number of neighboring protons equal to 3, you are getting a quadret with intensity 1 is to 3 is to 3 is to 1. So either from the Pascal's triangle or from the coefficient of expansion r plus 1 raised to n, you can calculate the intensity of the subsignal. So what is spin-spin interaction? Under low resolution, you are getting a signal for each set of proton. The signal position will be left to the signal of TMS, because most shielded protons are the TMS protons which are at upfield. Our compounds give signal left to the signal of TMS. Now when you take the spectrum of a compound under high resolution, under higher magnetic field, each proton, each set of proton, that will be splitted due to the interaction with the neighboring magnetic moment of the protons or neighboring protons. So due to the neighboring group participation, neighboring proton interaction, each signal will be splitted. So the protons present in a signal, the protons present in a set, that will not interact. Suppose they present 3 protons, CS3 group, all the 3 protons are alike. Similar protons will not interact. So the CS3 protons are similar, and that get affected only due to the presence of a neighboring proton. Remember that the protons present or hydrogen atoms present in a group, they are similar to one another. They will not interact. So all the members of a family, they are similar. They cannot quarrel with each other. The quarreling occurs with only neighbors. That is a general policy. That is a general concept. Like that, all the protons of a group, all the protons present in a group, they are similar to one another. They cannot interact. They will not cause any splitting. The splitting of a signal is caused by the neighboring group. Neighboring, the group present to the left or the right, or the proton present to the left or right. Here you consider only the protons. Here you consider only the hydrogen atoms as the neighbor, not the carbon, not the halogen, not any other group. Because we are discussing only NMR, that is PMR, the NMR of the proton, NMR of the hydrogen atom, right? So what is SS interaction? Once again, SS interaction is the interaction between the spin of the neighboring protons with the magnetic moment of the applied field, right? Due to the spin-spin interaction, each set of proton gives a multiplet. Sometimes a singlet or a doublet or a triplet or a quadret, like that. The number of the subsignal in a set depends on what? Depends on the number of the neighboring protons. Remember that. You give extra care to the neighboring protons when you consider the spin-spin interaction or when you consider the multiplet structure. So, how many subsignals are getting? In order to calculate the number of subsignal in a set, you just notice the number of neighboring protons, right? The number of neighboring protons is denoted by n. There present n plus 1 signals, subsignals for a set, right? The intensity of the signal can be calculated using either the Pascal's triangle or from this the coefficient of this expansion r plus 1 raised to n. In that way, we can calculate the intensity of the subsignals, right?